Good afternoon, everybody. My name is Kamerhon. I'm a fifth-year senior engineering major here at LSU. And today I'll be talking to you about the gas turbine electrical generation system that we'll be testing today. So some of these experimental goals would be to include the better understanding of the system and how a gas turbine electrical system works. More importantly, how a gas turbine would be able to even power an electrical system. The details of the generator and the engine, of course, will be going over the coefficient of performance and whatnot, the controls that operate them. We're also going to want to plot data for the analysis and performance calculations, as I was just speaking of. We're going to probably use the first law of energy conservation to calculate the system performance. As we're familiar, the first law of energy conservation is very similar to the first law of thermodynamics. Can't create, destroy mass, et cetera, et cetera. We're going to calculate system performance at specific points, so at the compressor inlet and at the outlet nozzle. We're going to then find the most efficient or effective operational settings to calculate the fuel power ratio when we're generating electricity. So when we're running the system, how we want to have this system run, so we can know what happens or what is happening when it's not running at full performance. So how does it work in particular? Well, this is something like a graph that you're going to see eventually, but mainly air is intake through the inlet valve. It'll be spun around by this fan where it'll go through some pressure stage. It'll then come here where it'll be heat will combine with the air and through combustion, and that will increase the temperature. It'll be pushed out here. This air is at a very, very high velocity at this point. Therefore, spinning this fan. This fan is attached to a turbine. A rotor. So, which will then turn this generator, which this generator has electrical coil in it and probably magnets to generate electromagnetic current, and that's where the generator will make some electricity. We'll have all these system performances on our chart. You'll see it when we get to the experiment, but not these exact ones, but some of the things like the temperature and whatnot, the speed, the inlet pressure, all that. So how does this work? All this was theorized, or the beginning of all this was the Brayton cycle. And Brayton this cycle is most famous for explaining how fresh air goes to a compressor, goes to combustion with fuel, then turns to turbine to get some work out. And you have exhaust gases, of course. So according to this PV diagram, you have, starting at 1 and going to 4, 1 to 2, you have the S is constant, P is increasing, then 2 to 3, you have the QN, which is heat, but the pressure stays constant. 3 to 4, S is constant, but you decrease in pressure, and then 4 to 1, the Q goes out, and that's all that heat, the exhaust gases. Something kind of similar for the T to S, 1 to 2. 1 to 2 is increasing temperature. 2 to 3, the P is constant, but the temperature increases. 3 to 4, temperature decreases, and then 4 to 1, the Q is out, and all those exhaust gases go out as well. Some of the apparatus, some of the software that we'll be using includes the computer with the TurboGen software. So when we go out there, we'll see a computer that'll be hooked up to the generator that'll show us some of the data that we will use to see the system calculations, the performance calculations. We'll see the control panel, which are different gauges and whatnot that we'll be able to read for ourselves. The turbo gas electrical generation system itself is actually quite small. If I remember correctly, the compression ratio was, if it wasn't 3.5, it was 4.5 to 1. But compared to say commercial jet engine that can be anywhere from 28 to 40 to 1, it's relatively small. There we go. Now the procedure to do all this includes conducting a pre-start inspection. That's making sure your area is clean, make sure you have the proper PPE, making sure that everybody knows the rules, safety guidelines, and whatnot. Starting the operation according to the manual. We definitely want to follow the manual for this. It could be more of a dangerous experiment. We want to collect the data and then shut down according to the manual. Now the manual says that we just want to run the initial startup and then start down at first. Not exactly sure if we're going to be following that specifically, but The second part is to create plots from the data collected in preparation for system performance calculations. So we'll be, we'll be creating the data from multiple different system performance levels, and therefore we'll want to create the plots to try to compare them so we can find the most efficient one. We'll perform the different analysis calculations, and then we'll perform the calculations and analysis for the generator portion of the rig. They want us to do it at specified points, mainly the compressor inlet and the outlet. And then, of course, we want to see how the generator runs at different points. So the results from this lab will be based on the settings that we explored. The different various settings that we're going to set it to. And some of these different settings include the current, voltage, power, RPM, pressure, just different things that we're going to toy around with to try to get the system as efficient as possible. That's everything. Are there any questions? Sure.
So is this the same type of basically setup that you would see in jet airplanes?
So the question was, if I understand correctly, is this the same type of setup that we'll see in jet airplanes? Is that correct?
Well, jets.
Jets.
Yeah, I'm gonna throw in airplanes in there, just jets.
Yeah, I understand. Jet engines, jet planes. Yeah, I got you. So, in essence, technically yes. However, it's not exactly the same. In a jet engine and jet planes, you'll see that the engines themselves, like I was saying earlier, have a much higher compression ratio. Sorry, I can't speak today. But that's only due to its like much higher need for that thrust. But however, through technological advances, it still powers some, like they still use some of that energy from the engine, especially once it's in flight, just cruising. They use some of that energy to power the electrical turbine as well. However, this apparatus is specifically set to create electrical energy, not necessarily for any other use, as opposed to where jet engines used mainly for travel. I'm sorry if that doesn't completely answer your question. Okay. Perfect. But are there any other questions?
I think we should keep rolling along.
Okay. So